All right, let's begin with the topic, new topic, trigonometry. Trigonometry we studied in AS as well, and inshallah now we are going to continue in A2. The AS trigonometry is very essential before you understand A2 trigonometry, because AS trigonometry gives you the foundations, right? And in AS we used to study three functions: sine, cosine, and tangent. Now we are going to study more things, and the first part is studying reciprocal trigonometric functions. So the reciprocal of sine function is called cosecant. The reciprocal of cosine function is called secant. In short form, we say sec and cosec. And the reciprocal of tangent is cotangent, cot. So we call sine, cos, tan. We call cosec, sec, and cot in short form. So sec x is 1 upon cos x. We know we have studied graphs of sec. Sorry, we have studied graphs of sine, cosine, and tan, right, in AS. And we know that sine and cosine both have to be between -1 and 1. No matter which angle we take, the answers will always be from -1 to 1. So sec x is 1 over cos x for cos x not equals to 0, because we know that the denominator can never be 0. So sec x will be undefined when cos x is 0. So the question is, when will cos x be 0? So if you recall the sketch of the cosine function, it was like this, right? It was like this, and we know that at 90 degrees and at 270 degrees, the cos x was 0. So cos 90 and cos 70, 270, sorry, cos 90 and cos 270 equals 0. So this means sec will be undefined when x is 90 or 270, because if cos x is 0, then sec x will not be defined. So sec x is 1 over cos x, but cos x should not be equal to 0. Then cosec x is 1 over sin x, but sin x should not be equal to 0. Then cot x is 1 over tan x, but tan x should not be equal to 0. Now, usually there's a misconception, there's a common error. The students think that sec x is the reciprocal of sin x because they match s with s. Now, this is a wrong concept. They try to match c with c, and they say that cosec x is the reciprocal of cos x, but this is not the case. So here we always tell students that they always need to remember the third letter. If it is sec x, it is secant, then c stands for cos. So it is the reciprocal of cos x. If it's cosec x, then the third letter is s. So it is the reciprocal of sin x. If it is cot, the third letter is t. So it is the reciprocal of tan x. So no matter which reciprocal function you are talking about, if we just check out its third letter, we will be able to recall that this reciprocal function is the reciprocal of either sine, cos, or tan. Sec x, third letter c, reciprocal of cos x. Cosec x, third letter s, reciprocal of sin x. Cot x, third letter t, reciprocal of tan x. ये हो गई आपकी पहली बात, याद रखने का तरीका, how to retain this in mind. Then we know wherever required, I'm going to recall AS trigonometry, inshallah. But I cannot teach fully, but definitely I'll try to recall wherever possible. So we know that there are 4 quadrants. This is the first quadrant. The 4 quadrants are in anti-clockwise sense. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. In first quadrant, we know all trigonometric ratios are positive. In second quadrant, we know only sine positive. So sine positive and the reciprocal of sine will also be positive. So now we are going to say sine as well as cosec will be positive. Will be positive. Sine and cosec will be positive. In the third quadrant, we know that tan is positive, and along with that, cot will also be positive. And in the fourth quadrant, which will be positive? So in the fourth quadrant, we know that cos is positive, so its reciprocal sec x will also be positive. So cos and sec both will be positive. So sine cosec in the second quadrant, cos and sec in the fourth quadrant, tan and cot in the third quadrant. You must remember A, S, T, C. Add sugar to coffee, right? A, S, T, C. Add sugar to coffee, just for remembrance. All silver tea cups. My teacher, when taught me many years back, she told me, all silver tea cups. Okay, so this is another short form for remembrance. So if A positive, then all 6 trigonometric functions are positive. If sine positive, then its reciprocal cosec also positive. And tan positive, its reciprocal cot also positive. If cos positive, its reciprocal sec also positive. Okay, so we have discussed that now there are not only 3 functions, but now there are 6 functions altogether. 3 trigonometric, 3 basic trigonometric functions, sine, cos, and tan, and 3 reciprocal trigonometric functions, sec x, cosec x, and cot x. However, in the calculator, we don't have options of sec, cosec, and cot. So let's suppose if I have to solve an example like the given example in front of you, the equation is cot x equals 4/3, and we need to solve it for 0 to 360. So whenever we see a reciprocal function, we know that it is cot x and the feature is not available on the calculator. So we need to convert it, right? For converting, we can either write 1/10x in place of cot x. 1/10x equals 4/3, and then cross multiply to get 10x equals 3/4. But this step is not essential. So what we can do is, okay, I'm writing this as well. We can do like this. 1/10x is equals to 4/3. And then we can write tan x equals 3/4. However, this step is optional. And it's better that you do directly. How? Because cot x is 4/3. So we know that tan x, cot x is the reciprocal of tan x. So if cot x is 4/3, tan x will be 3/4. We reciprocated the function, the fraction. We are taking tan x in place of cot x. So 4/3 will become 3/4. As simple as that. Tan x equals 3/4. Now the process will be the same as we studied in AS. Tan x is 3/4. So the steps were tan of an angle is positive. So first identify the quadrants. Step number 1. In AS we studied step number 1. Identify the quadrants in which the angle lies. So the quadrant would be first quadrant, third quadrant, because tan of an angle is positive in first and third quadrants. Then we need to find the basic angle alpha. For basic angle, if tan x is 3/4, tan of basic angle will also be 3/4. So we always say that whether tan of an angle is positive or negative, tan of the basic angle will always be positive. So tan alpha will be positive 3/4. And that is why we say that whenever, even if here it was negative 3/4, we would have taken positive 3/4 when taking alpha with tan. Because alpha is an acute angle. It lies between 0 and 90, or if we call in radians, it lies between 0 and pi/2. It is always acute. It has no direction. It is always positive. So for finding the basic angle, we always need to ignore the negative sign. And that is why alpha will be equals to tan inverse of 3/4. Then we need to remember another thing, identify the quadrants, then finding the basic angle, and then changing the domain if required. But in this question, domain changing not required. The steps were change domain if required, and then find final answer. We also need to remember that if it's angle in degrees, if the angle is in degrees, then we need to do workings in 3 decimal places, and the final answer must be given correct to 1 decimal place. So for degree angles, the requirements are different. However, for angle in radians, or for non-angles, whether it is angle in radians or it is non-angles, the working will be in 5 significant figures, and the final answer will be in 3 significant figures. So always remember that angle in degrees and angle in radians have different rounding of requirements. Angle in radians has the same accuracy guidelines as non-angles have. Like when we are finding area, when we are finding the perimeter, when we are finding the lengths, whatever we are finding, general instruction says non-exact answers to be given correct to 3 significant figures unless otherwise stated. If there's something different requirement mentioned by the examiner, we need to follow that. If nothing as such is mentioned, then we need to work. We need to do workings in 5 SF, and final answer will be given correct to 3 significant figures. And if it's angle in degrees, then answer has to be given in 1 decimal place. So working should be 2 accuracy higher, that is 3 decimal places. So this is what we are going to do over here, as the domain was in degrees. How do we know that we have to work in degrees or radians? We have to check out the domain. As the domain tells us over here that the angle is in degrees, so we need to work completely in degrees over here. Calculating tan inverse 3/4 will give us 36.869. And if we are rounding off to 3 decimal places, it will become 870. 36.8698. So it is rounded off to 870 degrees. Then once we have found alpha, we can find x. So we know that in the first quadrant, theta equals alpha. In the second quadrant, theta equals 180 minus alpha. In the third quadrant, 180 plus alpha. Fourth quadrant, 360 minus alpha. Over here, we have 2 quadrants. Basic angle alpha is always with the x-axis. So from here till here will give us 180 plus alpha. So we have 2 answers of x. One of the answers is alpha itself, and another answer would be 180 plus alpha. And then we are going to round it off to 1 decimal place as well. It is going to be 36.9 degrees And then if we are going to add 180 to it, it is going to be 216.9 degrees. So x equals 36.9 and 216.9 degrees. Right? So basic trigonometric function, basic example of reciprocal function. We converting that to normal function first and then solving in the same way as we used to do in AS. Right? So this is the first aspect that was to be discussed. If you have noted down already, or if you have not noted down, please note it down and then type clear and done so that I can move forward. All right. Alhamdulillah. Clear till here. Moving forward. Trigonometric identities which are already given in MF19. So if I just open the MF19, then there are 4 identities given to us. 1, 1, 2, 3, and 4. Right? And over here we see that there are 5 identities altogether. 1, 2, 3, 4, 5. So we have this, and this given in the formula sheet, MF19. And the third one is very simple. As tan x is sine over cos, so cot will be cos over sine. So starting from number 1, we already studied the first 2 in AS, P1, right? Sine square x plus cos square x is identical to 1. So from here, if we are going to make sine square x the subject, then it is going to be sine square x is identical to 1 minus cos square x. And if I talk about cos square x, then cos square x is identical to 1 minus sine square x. And from here, we also know that one of the identities that we have studied in O levels and IGCSE is a square minus b square is identical to a plus b, a minus b, a plus b. So using this identity, 1 minus cos square x is basically 1 square minus cos square x. So it is a minus b, a plus b. So using that concept, we will write 1 minus cos x, 1 plus cos x. So at times when we are proving identities in AS, we had to do like this, right? We used to simplify like this. Then in numerator, we used to get this, and the denominator, we used to get this, and we used to cancel out it with the numerator or denominator, and we used to simplify it. So this was one identity that was commonly used. In AS, we used to use the first two. Along with that, we also used to use the O-levels identity and for simplification and for proving of identities. Similarly, from here, we are going to get 1 minus sin x multiplied by 1 plus sin x. Right? So this is very commonly used. We'll see again in future. Then tan x is identical to sin x over cos x. And tan x is always defined except for those values of x for which cos x equals 0. That is why we used to see that cos x is 0 at 90 and 270. And when we used to draw the graph of tan x, at 90 and 270, there were asymptotes. Asymptotes are lines where curves never meet. Curves get very close to these lines, but never meets them. So x equals to 90 and 270 were the lines at which the asymptotes of tan x graph were made. Why? Because cos x is 0 for 90 and 270 degrees. Or if we talk about radians, then at pi by 2 and 3 pi by 2, cos x is undefined. Cos x is 0. That is why tan x will be undefined on those for those values of x. So if cos x equals 0, then tan x will not be defined. So tan x is always equals sin over cos except for when cos x equals 0. So cos x should not be equals to 0 for tan x to be defined. Then if we talk about cot x, then cot x is the reciprocal of tan x, as we have already seen. So if tan is sin over cos, then cot will be cos over sin. So cot x is cos x over sin x and will not be defined when sin x is equals to 0. So cot x will be cos x over sin x, but sin x should not be equal to 0. AS identity, using the concept of reciprocal function, the third identity also checked out. Now the fourth and fifth, as we have seen, are there in the formula sheet. Although no one is going to ask us how we have derived it, but we should know that if we divide the first identity with cos square x, we will get the fourth identity. If we divide the first identity with sin square x, if we divide the first identity by sin square x, we will get the fifth identity. Let's see how. The first identity, if we divide by cos square x throughout, then what will happen? Sin over cos is tan. So sin over cos square will be tan square. Then cos square gets cancelled. Then 1 over cos is sec. So 1 over cos square will be sec square. So always remember that if you are squaring both the sides, then if tan x is sin over cos, then tan square x will be identical to sin square x over cos square x. Similarly, if we talk about sec x, as sec x is 1 over cos x. So if you are going to square both the sides, then square of 1 is 1. The square of cos is cos square, so we'll get sec square x. So dividing the first identity by cos square x will give us sin over cos. Sin square over cos square will give us tan square. Cos square over cos square will give us 1. 1 over cos square will give us sec square. Similarly, if we divide the first identity by sin square, then sin square over sin square will give us 1. Cos square over sin square will give us cot square, and 1 over sin square will give us cosec square. Although no one is going to ask us, but we need to know how the fourth and fifth one are derived. So basically, these two are the main identities. Using the second one, we derived the third one, and using the first one, we derived the fourth and the fifth one. Also, we need to tell you another thing. Sin square x plus cos square x is identical to 1 is usually proved in books using Pythagoras theorem. We know that Pythagoras theorem is hypotenuse square is equals to base square plus perpendicular square. So using that, the first identity is derived. That is a long derivation, and we don't need to actually know it because we just need to use it, right? So if we know that this identity has been derived using Pythagoras, then this means the fourth and the fifth one will also be derived using Pythagoras. So at times in marking scheme, the examiner writes use of Pythagoras. Use of Pythagoras. The use of Pythagoras would actually mean the use of identities 1, 4, and 5. So please don't get confused if the words Pythagoras is used, because if we see that, then there is no direct application of a Pythagoras in those questions. But why has the examiner written the word Pythagoras? Because identity 1 has been derived using Pythagoras, and on the basis of identity 1, we have derived the fourth and the fifth one. This means we can say that all three are derived using Pythagoras. So that is the use of Pythagoras would mean use of any one of these three identities, 1, 4, and 5. Now, whenever we are going to solve a trigonometric question in A2 in P3, we are going to open that section of formula sheet in which trigonometry portion is there. So it is the second page, and the trigonometry portion is this. This is the trigonometry function. Trigonometry section. So we have seen this, and this, right? And then inshallah, soon we are going to discuss this as well. Today it's possible, then today, or might be a portion of it in the next class as well. So this was the first thing, right? So I think you have noted it down as well, and you are clear as well. Just acknowledge by writing clear and done so I can move forward. If there's anything you need to ask, you can definitely ask, or you can just move forward. We can just move forward and you can acknowledge, right? All right, moving forward towards the example. Solve the equation tan theta plus cot theta is equals to 4 for 0 to 360. So just tell me, what are we going to do? How to solve it? Any suggestions? Might be you can raise your hands and participate, or you can participate on chat as well. Okay. Hmm. Always think first before solving. It is very essential that you give it a thought and you consider more options as well. Might be the option that you are considering at the moment is going to be a dead end, or might be it is going to create some problems for you as you progress towards the question, as you progress more toward in that question. So over here, few students are saying use sine over cos in place of tan and cos over sine in place of cot. Yes, that is also a possibility, but in that case, sine and cos, two trigonometric functions will be involved. When we are solving a trigonometric equation, there has to be just one trigonometric function. If there are more than one, like if there are two trigonometric functions, then at some point in time, we need to do something to convert those two trigonometric functions into one single function and then only we are able to solve it. If we want to solve it, yes, now it's the correction, right? The ones who were previously saying write sine over cos in place of tan and cos over sine in place of cot, now they have corrected that we already have one trigonometric function with us, that is tan, and the another function cot, which is a reciprocal function, we can write 1 over tan in place of that. So yes, this is the smartest option. So let's follow that. Tan theta plus 1 over tan theta is equals to 4. So now then we are going to take LCM, or we can say that we multiply. Yes, the best approach is tan theta is LCM. So if we take tan theta as LCM, then this is going to be tan squared theta plus 1 will remain plus 1, and the denominator will be cross multiplied with 4 to gives us 4 tan theta. I hope you have understood this step. This was 1. We have taken tan theta as the LCM. So this will become tan squared theta. This will remain 1, and the tan theta will be cross multiplied. On the other side, there was no tan theta over here. It was over here. Then we cross multiplied. So it went there and we got 4 tan theta. Then we bring the entire equation to one side. Always remember that if you are given a particular page, then always work on the left side so that even if you need more space, there is blank space on the right side. So just make 2 portions. Convert your single page to 2 pages so that you get more working space, right? So tan square theta minus 4 tan theta plus 1 is equals to 0. Then what you can do, then you have to first check out whether you can do middle term breaking. Is there any possibility of middle term breaking over here? If you can factorize it. So if you can factorize, this is a quadratic equation, by the way. You can also write like this, tan theta equals a. And then you can say a square minus 4a plus 1 equals 0. But this option, this is not essential, right? Assuming it to be a and then finding a and then finding the tan theta and then finding theta at the end is more time consuming. So if you have already identified that this is a quadratic equation, you can directly do middle term breaking. And if middle term breaking is not possible, you can directly use the quadratic formula. So when it was x squared minus 4x plus 1 equals 0, then the quadratic formula was giving us x. X equals minus b plus minus root of b squared minus 4ac upon 2a. But over here, it's tan theta. In place of x, there is tan theta. So tan theta is equals to minus b, so minus of minus 4, plus minus square root of b square minus 4ac. The coefficient of tan squared theta will be 1, which is a, and c is 1, divided by 2 times a, and a is 1. So now from here, we are going to get tan theta. And also please remember, few students directly use the quadratic formula to give the values of tan theta. No, this is not acceptable. Why? Because the examiner specifically sets method marks in the marking scheme. And if you get a 0 method mark, then you are going to get a 0 in the accuracy mark as well. So even if you have got the correct answers of tan theta using your calculator, you will not be awarded marks because you have not shown the method. So either you are going to show the factorization, or you are going to convert into completed square form, which is more technical, of course. So we usually prefer 2 of the methods. Altogether, there are 3 methods for solving: factorization, quadratic formula, completing the square. But usually we first prioritize factorization. Then if factorization is not possible, we move towards quadratic formula. So over here, we are going to use the quadratic formula, and that is going to be tan theta is equals to 4 plus minus root of 16 minus 4 will give you 12 over 2. Yes. No calculator for quadratic equations. You can just use the calculator to find the roots, but for checking purposes. At least this step is minimum. At least show this step. Like let's suppose if you're not interested in showing this step, this is optional. Let me write this. This step is optional. This is optional. At least showing the application of quadratic formula was mandatory. This is a mandatory step. You cannot avoid this, no matter what. This is mandatory, very essential. Because it shows that you have solved the quadratic equation using quadratic formula. So this is for method marks. We'll award method marks. Mandatory for method and accuracy marks. Why? Because if method marks are not awarded, you will also lose the accuracy marks, even if you have given the correct answer using your calculator. Now, usually students at times do not know this in AS because they have studied from a different teacher and their teacher might not have emphasized on this. But we have attended several Cambridge trainings in the past. And the examiner has told us that showing all essential steps is very essential, including the use of quadratic formula wherever required. So the optional step, if you are not writing the optional step, then what we are going to do? Then after writing this application of quadratic formula, we can directly write the decimal versions of this using your calculator. So this step was mandatory. Even after that, if you use calculator and put this inside your calculator and give the values of tan theta directly, that is also possible. If you use this to convert into decimal, that is also possible. So over here, if I convert this into decimals, it's going to be 4 plus root 12 divided by 2. And if now, because we are working, but working should be in 5 significant figures. 3.7321. Or another possibility could be tan theta is equals to 4 minus root 12 upon 2, which will give you 0.26795. Then the steps are repeated. Tan of an angle is positive in the first and third quadrants. Then you find the basic angle alpha. If you are going to find the basic angle alpha, then take tan inverse of 3.7321. Now you're working in degrees because the domain is in degrees. The basic angle you are going to get is 75.0001888. Even if you're working in three decimal places, it is going to be 75.000. No need to write this. It's basically 75. It's approximately 75 degrees only. And then the first quadrant, angle x, sorry, it's not x, it's theta. Theta is going to be 75 degrees. And 180 plus 75 in the third quadrant, we're going to get 255 degrees. In one decimal place, if you are going to give the answers in one decimal place, then it is going to be 75.0 degrees. What is the difference between 75 and 75.0? It's just the impact that it creates. 75 is an integer. It seems that the answer was an integer, but 75.0 tells you that the answer was not an integer, rather you have rounded off, and then you have got the final answer. Yes, but the problem was that there was a rounding off error. That is why, so over here, then placing a decimal is not essential. Why? Let me tell you one thing. If you calculate 4 plus root 12 divided by 2 and you take a tan inverse on that directly, then the basic angle the calculator is giving is 75. Tan inverse of 4 plus root 12 upon 2 is 75. So this 0.000 is basically the rounding off error, because we have used 3.7321, which is a rounded off value. That is why we are getting this answer. If we would have taken the exact version, we would have got the exact value of alpha, that is 75. So this means over here, the exact integer answers could be given, and those could be 75 degrees and 255 degrees. Then also, if we take tan inverse of 4 minus 12 upon 2, it is going to be 15 degrees. So from here, the basic angle that we are going to get is going to be 15 degrees exact. If you're going to take 0.26795, then there's going to be a rounding of error. But if you're going to take the exact version, 4 minus root 12 upon 2, then we are going to get 15 only. In the first quadrant, it's 15. In the third quadrant, it's 180 plus 15, which gives you 195 degrees. We have given answers from here as well, and we have got 2 answers from here as well. So altogether, there are 4 answers, 4 values of theta, which satisfies this equation. You can also check out as well. Tan 75 plus 1 over tan 75 gives you 4. If you put in 75 degrees in this equation, you'll get 4. Then in place of 75, if you are going to write 255, if your calculator is an advanced version, you can type x in place of that, in place of angle, then press the calc key. If you're going to press 75, you're going to get 4. If you're going to write 255, you're going to get 4. If you write 15, then also you'll get 4. If you write 195, then also you get 4. So basically, if you're going to put the values of theta, all these 4 values of theta will satisfy this equation. And at all times, you are going to put in theta in this equation, you'll get 4 for all the 4 values. So this was the example number 1 that we have fully understood. Just note it down and let me know if everyone is clear with all the steps. And once you are done, just give an acknowledgement, done and clear, so that we can move forward. All right, moving forward towards the example number 2. Solve the equation 2 sec square theta minus tan theta is equals to 5 for theta lying between 0 and 360. So again, we are seeing a different function over here, sec square theta being involved. So we have multiple options. We can recall what is sec. Sec is 1 over cos. So we'll say, okay, sec square is 1 over cos square. Then we tried to recall tan is sine over cos, but then we decided, oh, there's sine and cos both involved, then we might get stuck. So what is another possibility? So I always tell students that whenever you are solving a trigonometric question, always open this particular page from your MF19. In your MF19, open this page. Inshallah, something or the other you are going to recall for sure. So because sec square equals 1 over cos square was not that suitable in that particular question. So this identity worked. Sec square theta is 1 plus tan square theta. So if we replace, then sec square theta is 1 over tan square theta, 2 times 1 plus tan square theta minus tan theta equals 5. If you multiply 2 plus 2 tan square theta minus tan theta minus 5 equals to 0. Then it becomes 2 tan square theta minus tan theta, and 2 minus 5 is minus 3 equals to 0. Now this is again a quadratic equation. If middle term breaking is possible, we should do middle term breaking, which means we should do factorization. If it's not possible, then we should go towards quadratic formula. If factorization is possible, then also some students says that, sir, we are more comfortable in the usage of quadratic formula. No issues at all. Whichever way you are comfortable, you can do that. However, if there's middle term breaking possible, you can go for that. So if I check out, then without any substitution, you can also use tan theta equals A and then form a quadratic equation in terms of A and then middle term break, or you can directly middle term breaking as well. You can do directly middle term breaking as well. 2 tan square theta minus 3, 2 is minus 6 tan square theta. So it's minus 6 means this is minus 3, multiplying the first and last terms. It's minus 6 tan square theta. The factors could be minus 3 plus 2. Because minus 3 plus 2 will give you minus 1, and minus 3 multiplied by 2 will give you minus 6 as well. So I can write minus 3 tan theta plus 2 tan theta minus 3 equals to 0. You can take tan theta as common from here. It will give you 2 tan theta minus 3. And from here we can take 1 as common. So we are going to get 2 tan theta minus 3 equals to 0. Then we'll get tan theta plus 1. Then we'll get 2 tan theta minus 3 equals to 0. We have got two possibilities. Tan theta equals negative 1, or tan theta, 2 tan theta minus 3 equals 0, or tan theta plus 1 equals 0. So tan theta from here you will get 3 over 2. So tan theta equals negative 1 or tan theta equals 3 over 2. Then we identify the quadrants, second and fourth. Tan is positive in first and third, and negative in second and fourth. The first step, finding the basic angle. For basic angle, we ignore the negative sign. So tan inverse of 1, we get 45 degrees. And from here, if we find the basic angle, then tan inverse 3 over 2 will give us a decimal value 56.3099, rounded off to 310. 56.310 degrees. Then finally, we give the answers of theta. The first answer in the second quadrant, 180 minus 45 is 135. And in the fourth quadrant is 360 minus 45, which is 315 degrees. Then from the second possibility, we can get first and third quadrant. In the first quadrant is basic angle, which is 56.3 degrees. In the third quadrant, it is 180 plus 56.3 degrees, which is 236.23 degrees, 263.3 degrees. So we are going to get 4 answers. We can write like that as well. We can write directly like this, or we can also arrange in ascending order and then write. Although arranging in ascending order is not going to give you any more credit, but this is at times the examiner's style of giving the answers, but that is not essential. In any order, the answers can be given. So theta equals 135 and 315, and theta equals 56.3 and 263.3 are the 2 answers that you had to give. No, sorry. 263.3, my bad, wait. 180 plus 56.3 is not 263, it's 236. My bad, sorry. What I've done is I've subtracted from 360. What I've done? क्या कर दिया मैंने? गलती हुई है. तनी क्या किया? Second column में 180 minus 45, 360 minus 45, तो 315 and 135. First quadrant में 56.3 and third में 180 plus 56.3 will give you 236.3. कोई ऐसी गलती हो जाए ना मुझसे तो मुझे बता दिया करें, सही है? If there's any error, please let me know so that I can correct. Don't know how I have written that. कैसे क्या मैंने टाइप किया कि सही हुआ? क्योंकि अगर मैं 360 माइनस भी करता हूँ तो वो आंसर नहीं आता जो मैंने लिख दिया था. हाँ, पता नहीं क्या किया. 180 plus 56.3 will give you 236.3 degrees. सही है, सब चेक भी किया करें, साथ साथ कैलकुलेट भी किया करें, अंधाधुंध खाली कॉपी ना करें, बल्कि मुझे बताए भी अगर करेक्शन हो तो. सही है. So we are done with example number 2. Just let me know if you are clear with it. You can also go back and check that. Q tan x whole square minus tan x minus 3. Calculating 135, yes, it's 0, 315, it's 0, 56.3 is approximately 0, 236.3 is also approximately 0. Yes. Perfect. Yes, we have solved. You have solved the second example as well. If you have written and you have also understood, just acknowledge with done and clear so we can move forward. Moving forward towards compound angle formulas. In AS, you people have been taught, and you should always remember that this is a table that everyone needs to remember. Although this is a part of our syllabus since the time when the calculators were not those, the calculators were not so smart enough to give fractions. Because when I used to give my exams of O levels and A levels, the calculators I had was not uh, never used to give the answers in fractions. It used to give the answers in decimals. So we were always told to remember this table. But now, at times where the examiner has specified that the use of calculators are not allowed or do not use a calculator, then these three values the calculators will give you after rationalization. Because as per the maths rule, whenever there is a surd, this means whenever there's a root, these roots of imperfect, the numbers which are not perfect squares, if we are going to take square root of those numbers, we are going to get surds, right? So we say that root 2 is a surd. Whenever there are surds in the denominator, the calculator rationalizes it and gives you the answer. So if you're going to type in sine 45 on your calculators, just type sine 45 and you'll get root 2 over 2. The calculator will give root 2 over 2. This means the calculator is rationalizing. So if there is nothing as such mentioned by the examiner that usage of calculator is not allowed in this particular question, then you can use root 2 over 2 as well in place of sine 45 wherever you need to substitute. But if it's written that calculators are not allowed, then you need to use 1 over root 2. Plus, we also see that at times the examiners use 1 over root 2 in their workings, and the answer that is given in the marking scheme is based on the usage of 1 over root 2. But also in the marking scheme, they say OE or equivalent. Although the equivalent forms are not given, but your answer by using root 2 over 2 can be in in OE if the decimal value of your answer matches with the decimal values of the answer given in the marking scheme. Marking scheme gives a particular answer and writes OE. So every other student think that their answer is or equivalent answer. But no, this is not the criteria that whatever you have done is right. If your answer does not matches with that of the examiner, then this means that you need to find the decimal version of your answer and the decimal version of the examiner's marking scheme answer and then match. If both decimal values match, then this means your answer is also correct answer. Why do we even have to find why are we not finding the decimal values initially only? Why are we giving in exact terms? Because that is the requirement of most of the questions in P3 as well. Give your exact answer. Give exact coordinate. Give exact values of angle. So whenever the word exact is written, always remember, even in AS, in circular measure or in different topics, whenever the examiner was writing the word exact, you are always guided and told that do not use a calculator in such questions. Work manually as much as possible, but do not convert into decimals. So even over here, whenever you are told to give the exact answers, then you should not convert into decimals. We have to work in exact terms. The bottom line is, it's very helpful to remember this useful table because as per the nature of sine, if we check out the graph, between 0 and 90, the sine increases. At 0, sine is 0. Then at 90, the sine 90 is 1. And between 0 and 90, sine keeps on increasing. So at 0, it's 0. At 30, it's half, 0.5. At 45, it's 1 over root 2, which is 0.7 something. At 60, it's 0.866 something. So it keeps on increasing. So even if you are going to remember this one single line, then we can remember the entire table. So sine 30 is half, sine 45 is 1 over root 2, and sine 60 is root 3 over 2. Then as per the nature of cos decreases between 0 and 90. At 0, it's 1, and at 90 is 0. And then the graph goes on. So between 0 and 90, the cosine graph decreases. So the value also decreases. So at 0, it's 1. At 30, it's root 3 over 2, 0.866 something. At 45, it's 1 over root 2, which is 0.7 something. At 60, it's half, which is 0.5. This means the cosine value is decreasing. As per the concept of complementary angles, sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. This is taught in AS. So this means sine 30 equals cos 60. Sine 30 equals cos 60. And sine 60 equals cos 30. And cos 45, sine 45 equals cos 45. Sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. So even if you are going to remember one line, half 1 over root 2 and root 3 over 2 for sine, then for cosine, the order is reversed. It's ascending order. For cosine, it's a descending order. Root 3 over 2, 1 over root 2 and half. Then we know that tan is sine over cos. Tan theta is sine theta over cos theta. So if you are going to divide 1 over 2 by root 3 upon 2, then 2 and 2 will get cancelled and we'll get 1 over root 3. Then 1 over root 2 divided by 1 over root 2 will give us 1. Then root 3 over 2 divided by half will give us root 3. So if you remember one of the lines, then reversing the order will give us the cosine line, and then dividing the sine and cosine lines will give us the tan line. The bottom line is, if the calculators are not allowed, all the other values will be perfectly given by the calculator. But these three values that I am circling at the moment will be given by the calculator in rationalized form, and we need to ensure that we remember these exact values. So sine 45 and cos 45 are 1 over root 2 and tan 30 is 1 over root 3. If nothing is specified, but the word exact is written, then it's entirely depends upon whether we use the memorized ones, the values that we have memorized as of now, or we directly use the calculator values. All right. So this table is something that we need to keep in mind. Now, compound angle formulas. What is the meaning of compound? Compounding, right? If compounds are formed, a mixture is formed. Compounding angles means combining angles. So when we are adding two angles or we are subtracting two angles, then compound angle formulas are used. So sine A plus minus B, cos A plus minus B, or tan A plus minus B. At times it's sine A plus B, at times it's sine A minus B. So over here, both signs are written just to tell that when we are expanding sign, then positive will give us positive, negative will give us negative. But in cosine, when we expand cosine using the compound angle formula, the plus minus gets converted to minus plus. This means if there's a addition over here, it will get converted to negative. And if it's a negative sign over here, it will get converted to positive. And in tan, there's a fraction involved. In the numerator, the signs are the same. For plus, it's a plus. For minus, it's a minus. But in the denominator, the signs are opposite. For plus, it's a minus. And for minus, it's a plus. Just to give that impact, both the signs are written in the same single equation. And these are also given in the formula sheet, as you can see. So this means they are already given in the formula sheet. The only thing that we need to do is to learn its application. We need to learn its application. So let's learn its application. Simplify the following. First, let's look at this. Sine A plus minus B. So it's sine A cos B plus minus cos A sine B. So if it was sine A plus B, then we would have written sine A cos B plus cos A sine B. With a plus, it's a plus. With a minus, it's a minus. So sine A plus minus B is sine A cos B plus minus cos A sine B. For cos A plus minus B, it's cos A cos B minus plus sine A sine B. With a plus, it's a minus. With a minus, it's a plus. So when expanding the cosine, when using compound angle formula for the cos, the signs gets opposite. While expanding an addition sign, we convert into negative, and when there's a negative sign, we convert into positive. So cos A cos B minus plus sine A sine B. Then tan A plus minus B is tan A plus minus tan B upon 1 minus plus tan A tan B. All three, these three are written in the formula sheet. We only need to learn its application. So if we talk about the first few examples, simplifying the following, the first one is sine x plus 30. So sine x plus 30 means in place of A, there is x, in place of B, there is 30, and we have been given the positive sign. So let's expand using this. Sine x plus 30 is going to be sine x cos 30. With a plus, it's a plus cos x sine 30. Simplifying it further, cos 30, we know from the table as well, it's root 3 over 2. So root 3 over 2 sine x plus sine 30 is half. So it's half cos x. So this was the expansion of sine x plus 30. Then if we expand cos x plus 30, so it is going to be cos x cos 30 minus sine x sine 30. So expanding the cosine, the plus sign gets converted into minus and the minus gets converted into plus. So cos x plus 30 is cos x cos 30 minus sine x sine 30. Then we know that cos 30 is root 3 over 2. So root 3 over 2 cos x, then minus sine 30 is half. So it's half sine x. Sine x sine 30. Sine 30 is half. So it's half sine x. So root 3 over 2 cos x minus half sine x. So you expanded cos x plus 30 using the compound angle formula of cos. Then moving on towards tan x plus 30. So it's in the numerator, it's tan A plus tan B. In the denominator, it's 1 minus tan A tan B. So if it's tan x plus 30, we are going to write tan x plus tan 30 upon 1 minus tan x tan 30. Tan x plus tan 30, 1 minus upon 1 minus tan x tan 30. Then because over here the fraction is being involved, the simplification gets more time. The simplification takes more time. So what we can do is we can divide it into two fractions. We can write like this: numerator divided by denominator, which might make it more convenient for us. So tan x plus tan 30. Tan 30, the value is 1 over root 3. Tan x plus 1 over root 3 divided by 1 minus tan x times 1 over root 3. I think this should be taken to upwards by resizing it a bit. Yes. And then after this, the next step would be taking LCM. So it's root 3 tan x plus 1 over root 3 divided by root 3 minus tan x over root 3. Then when we are going to reciprocate, because if division gets converted to multiplication, the fraction will get reciprocated. Root 3 will be cancelled with root 3. So we can directly cancel root 3 with root 3. And the final answer that we are going to give is root 3 tan x plus 1 divided by root 3 minus tan x. Right? So this is the simplification part that we have done for the first 3 examples using the compound angle formulas given above. Then the fourth example, in which 2 are combined, cos of x minus 30 minus 3 times sine of x minus 30. The cos of x minus 30 is cos x cos 30 plus sin x sin 30. For cos, the sign gets changed. Minus gets converted to plus and plus gets converted to minus. Then it's minus 3 times. Then we have to take within the brackets because minus 3 will be multiplied by the expansion of sin x minus 30. Sin x minus 30 is sin x cos 60 minus cos x sin 60. Cos x cos 30 plus sin x sin 30 minus 3 times sin x cos 60 minus cos x sin 60. So over here it's a minus, over here it's a plus, over here it's a minus, over here. So I got disconnected. I'm back. So we are discussing the fourth example. Cos of x minus 30 minus 3 times sine of x minus 30. Cos x minus 30 is cos x cos 30 plus sin x sin 30. Then sin x minus 60 is sin x cos 60 minus cos x sin 60. And whatever expansion we are going to get, we are going to multiply it by 3. So let's do this. Sin x cos 60, right? So cos 60 is half. So half sin x. Half sin x multiplied by minus 3 is minus 3 upon 2 sin x. Then cos x sin 60, and we know that sin 60 is root 3 over 2. Minus root 3 over 2 multiplied by minus 3. First, it was minus 3 over 2 sin x. Then if it's sin 60, root 3 over 2 multiplied by 3 minus gets plus. So it's plus 3 root 3 divided by 2 cos x. Now what we can do, root 3 over 2 and 3 root 3 upon 2 cos x at both the places. So we can add both of them. 3 root 3 divided by 2 plus root 3 upon 2. It's 2 root 3. 2 root 3 cos x. 2 root 3 cos x. And half minus 1.5. Minus 1. So it's minus sin x. So we have simplified. This is going to be our final answer, right? So I guess I have explained the compound angle formulas completely. And I have also I've explained the compound angle formula application using the 4 examples. And if you have noted down and you have understood as well, just acknowledge, done and clear. So we'll end the class over here, inshallah, and we are going to continue in the next class. Then, inshallah, in the next class, we are going to complete the explanation of trigonometry. By that time, if you have not completed any previous thing, make sure to complete it. Inshallah, soon you will be assessed as well. A test will be taken. And inshallah, I'll update the details on WhatsApp. Okay. For the first line in 4 example, why did you take minus cos x sin 60? Look, Ali. Compound angle formula for expansion of cos, if it's a minus, after expansion it gets plus. But if it's sine, then minus remains minus. Because minus 3 remains outside, and sine x minus 30, if expanded within the brackets, it's sine x cos 60 minus cos x sine 60. Then whatever answer we are going to get, we are going to multiply by minus 3. So here it was plus sine x cos 60 multiplied by minus will give us minus negative value. And then this minus and this minus will give us plus. Yes, carry on.
Can you scroll up? There is an example. I have a question. Yeah, in example number 1 and 2, can we square both numbers to get sine square plus cos square equals to 1?
No. This is not an equation. Carrier, this is an expression. Because sine x plus 30 was an expression, we had to simplify it. Squaring, whenever we do squaring, we do on both the sides. Whatever we do, we have to do on both the sides. But that is only possible when we are solving equations. If it was sine x plus 30 is equals to 5 or equals to 2 or some other number, then we might do squaring both sides. And over here, how can we square? We cannot simply square one single side. If there were two sides, we would have expanded. And even if then we would have expanded, then also we would not have got the answer that you are saying. You are saying that we can write sine square x plus cos square x. No, if we are going to expand it, carrier, then root 3 over 2 sine x plus 1 upon 2 cos x, if expanded using power 2, then we will not be expanding directly. We will be expanding using a plus b whole square rule. Using the identity, a plus b whole square is not a square plus b square. It's a square plus 2ab plus b square. Then expansion would create more difficulties for me. So there's no need to expand. We cannot expand because this is an expression, not an equation. Even if it was an equation, then also we couldn't have expanded the way you were saying. I think I have clarified now. Are you clear with it? Alia,
Yes,
you
sir.
also asked the question. Are you clear with the question? Any more confusions, Alia, or is it done?
Oh, it's clear, sir.
Okay, great. Okay, so just take a screenshot. You have already written as well. So if you want to take a screenshot, you can. So with this note that, Alhamdulillah, we'll keep trigonometry explanation till here only. We are going to continue the remaining explanation. Inshallah, we'll try to complete that as well in the next class. So see you all in the next class. Till that time, अपना बहुत सारा ख्याल रखें, दुआ में मुझे याद रखें और पुराना अपना सारा काम मुकम्मल करें. Complete your previous tasks and whatever assignment submissions or tests are going to come, I'll let you know, inshallah. Till that time, take good care of yourself. Assalamu alaikum wa rahmatullahi wa barakatuh.